not, then that would also be very helpful.
All right, so as Sam mentioned, our hypothesis was confirmed, but the problem with that is that we figured that out at 9 o'clock on our first night. So in order to make the most of our beam time, we decided to embrace a second project. So Searching for Selenium was born, and this project was suggested to us from Gosha. And in it, we compared the selenium speciation in several supplements, as well as nuts and seeds that are known to contain this element.
So selenium is a trace element that is key to human health, and it comes in organic and inorganic forms. The inorganic forms are selenite and selenate, and the organic forms are selenomethionine and selenocysteine.
And although the body can absorb all 4 of those speciations that she just listed, the organic ones are more readily absorbed by our bodies, so they're more bioavailable. And as well, elemental selenium is not bioavailable to us.
And so since selenium is key to human health, there is actually a very small threshold level in which it's helpful or harmful. You don't want to have an excess or an insufficient amount, or else that could be pretty bad for you. The recommended amount for adult males is about 55 micrograms a day. But the interesting thing to note about selenium is that in products that contain it, it depends how much selenium is in them depends on where they actually come from. It depends on the selenium content in the soil. So you could get Brazil nuts, which are up there from either Brazil or Bolivia, and it all depends on how much selenium is in the soil.
So our research was inspired by a recently published study, 2014 study, that was called the Baseline Selenium Status and Effects of Selenium and Vitamin E Supplementation on Prostate Cancer Risk. So a bit of a mouthful. But what it was a study that they did, and it took older men between about the ages of 60 and 70. And if Aaron goes to the next slide, they started with taking initial selenium levels, and they classified them as either low or high. And then over a period of about 10 years, they were given supplements daily of either selenium, vitamin E and selenium, or just a placebo. And so then at the end of the study, by looking at the number of men who actually did end up contracting prostate cancer, they were able to figure out a relationship between initial selenium levels, the supplement they took, and their risk for cancer. So the conclusions that we were most focused on were that men who had initially low selenium levels took vitamin E supplements, they ended up with an increased risk of prostate cancer, and men with initially high levels took selenium, ended up getting an increased risk. Everything else they all found ended up with no change. So what's most important to note is this is very different than a lot of studies that were done in previous years, which suggested that selenium actually decreases risk.
Okay, so our scientific question, we were looking at the speciation of selenium, as I said before, and we wanted to look at the speciations between supplements and between things that are found in nature, like Brazil nuts and mustard seeds. And we were really just looking at the bioavailability between the two.
And we were particularly interested in selenomethionine because, as Rowan just mentioned, that was the one that was mainly ingested by participants in the study.
So in order to test out the question, we first prepared the samples by crushing the nuts, seeds, and supplements that were supposed to contain the selenium with mortar and pestle. And after we powdered the samples, we applied Kapton tape on a sample holder and then put the powder samples into the hole of the sample holder. And after that, we cleared off the sample holder, the area around it, so that we can minimize the air that gets into the sample, and applied another piece of Kapton tape on top. And after preparing all the samples, we took the fluorescent, X-ray fluorescent scan of each of them, and we identified the elements that were present in all those samples. And doing that, we found out which type of the samples had higher levels of selenium, and we took vein scans of them, as well as of supplements that had different types of selenium listed on their label. and we analyzed the data that were collected from the Zanes to try to answer the question that we were asking. And here is the pictures of us collecting data. That was crushing the bristle nut, and that's us placing the sample on the bottom left, and we're cleaning the sample holder on the top, and just pictures of us preparing the samples.
Okay, so we used a two-technique approach. We were working on the ideas Beamline, and so we wanted to use XRF and Zanes. And with XRF, we were looking at the elemental composition of everything that the Beamline was able to measure that was within that within our samples. And then with Zanes, we looked more specifically, and we wanted to know the specific speciation of the selenium present inside the samples.
So a good way to think of the two beamlines would be using your hand, actually. Your hand would be the whole substance, and then the XRF, you would look at the elements inside, which could be maybe your fingers. And then the Zane scan would look more closely just at one finger in specific and look at the fingerprint, or look more closely at that one element.
All right, so this is a normalized graph for supplements and our natural substances. Essentially, they were all composed of the same elements. A couple anomalies existed. Some of the supplements, one might have calcium, one might have nickel, but no calcium. We just contribute that to different companies and how they manufacture. So we've got argon, calcium, iron, nickel, zinc, but what's interesting to point out is the varying selenium levels. This one is the Jameson's, which was the supplement that actually had the lowest selenium level. The other ones went much higher, those are also supplements. But this tiny little bump right here was the mustard seeds, which of the natural compounds, we had the highest amount. So there is much variation in the supplements and the organic compounds. Oh, and the reason we left one supplement out is one a day. It is a multivitamin, and as you'll see on the next slide, the zinc numbers were massive. This is the scatter here, and the zinc numbers are so close, they're so much higher. So therefore, we didn't put it on the graph because it wouldn't accurately represent what we were trying to display. So an interesting thing to note about this is the one a day contained elements that were not found in any other sample. Elements like vanadium, titanium, cobalt, in trace amounts, but we just attribute that to being a multivitamin, so giving you a little more nutrients and minerals.
So the second method we were using is Zane's, and this was done on the same Beamline. So the difference here is that while the XRF sample takes just the whole sample and looks at all of the elemental compositions inside of it, the Zane's takes specifically the parts of one element that we're looking at. So in our case, we're looking for selenium. So we had the 12,600 electron volts that are necessary to determine selenium. We put that specifically on the sample, therefore we were able to zoom in on those peaks. And the different peaks that we saw allowed us to look at the varied speciations of the selenium.
Sweet. So this is the data that we collected from the Zane scans. As you can see, the last one here is the mustard seed. It's just waterfalled up here, so they're not to the same scale. However, they are normalized to each other. Now, the 5 supplements up here show the different peaks in different places because they have different speciations of selenium, which you'll see on the next ones. So these colored peaks, they're from the literature. They're standards of what energies will attribute to the different speciations. So we have the 2 elementals, red and gray, are different allotropes, and then selenomethionine, which is our organic one that we like, and then the 2 inorganics, sodium selenite and sodium selenate. Our first one here, our supplement Organica, is supposed to contain the HBP chelate. Now that would go to our organic molecule, and as you can see, the vertical line here kind of lines up with that. So there's a good chance that our organic molecule of selenomethionine was present. The next one here is the Jameson. It was supposed to contain sodium selenite, and as you can see from the vertical line, it looks like it does. An interesting one was our one-a-day. So our one-a-day multivitamin, it was supposed to contain sodium selenate, which as you can see, a peak does line up with. However, the second peak very much lines up with the elemental selenium. We can attribute this to a couple different things. One of them would be beam damage. So the beam may have reduced some of our sodium selenate right back into elemental selenium. It's also possible that the label was wrong, and it did in fact contain elemental selenium because it was added. Our Swiss supplement was supposed to contain selenium yeast. Now, selenium yeast is a way of preparation of the organic speciations. It can contain anywhere from like 23% to 85% selenomethionine. All sorts of different things vary by brand. So that's why you'll see the peaks will be very different based on the samples, even if they all contain selenium yeast or HVP chelate. 2 peaks here suggest that sodium selenate is present, and down here selenomethionine is also present. Like I said, another selenium yeast, but the peaks are vastly different. Comes down to selenomethionine, perhaps some more sodium selenite in there.
So in order to analyze the data that we collected in the Beamlines, we first took the fluorescence scans and identified the elements that were present in each sample. And we also compared these graphs to see like what type of elements were present in each and what were different between the samples. And also we took the scans, printed them out, and looking at the graphs, we tried to identify any anomalies or the different speciations of selenium using the standards that were provided for us.